Pavilion, shattering performance expectations with testing with the Nvidia DGX-A. This presentation is designed to give an overview of the results of the performance testing and the value proposition Pavilion plays for Nvidia GPU-based solutions. This testing and performance numbers were actually validated by the Nvidia GPU Direct storage team. Pavilion has definitely caught the attention of Nvidia. Actually, at the supercomputer show in December of 2020, Michael Kagan, the CTO of Nvidia, referenced Pavilion. You can see the slide in this presentation where quotes came from him as it related to storage. I highlighted some of those quotes and related those to areas that Pavilion definitely can address. One of the things Michael said was high-performance computing requires high-performance I/O. Pavilion definitely addresses that. The rule is simple. The higher the processing power of the compute element, the more data it can process, hence faster data delivery is required. Pavilion's hyperparallel flash array and our performance, check. Performance improvement for file storage of almost 4x by using GPU Direct storage. This is relating to the purple box there, relating to Pavilion's testing of GPU Direct storage versus non-GPU Direct storage. The last quote that I thought was very important was, storage access is yet another bottleneck that needs to be resolved. This is in the context of feeding that beast of the DGX-A, and Pavilion definitely addresses that. So from enterprises to research institutions, we're really catching the attention of the data center solutions for Nvidia plus Pavilion. So whether you're looking at a DGX A100 or a GPU-enabled server in general, the match and complement that the Pavilion hyperparallel data platform provides is unprecedented. The GPU-based solutions, unprecedented compute density. The data platform Pavilion, unrivaled performance, scalability, density. As we look at the value propositions from Nvidia, create better models, faster and unmatched performance, you match that with Pavilion delivering data faster to accelerate model training, inference, and analyze larger data sets. We look at those GPU-based solutions achieve the highest compute density and performance in the smallest footprint. That matches Pavilion's strategy, achieve the highest performance density and lowest latency in the smallest footprint with unlimited scale. Back on the DGX DPU side, accelerate the development cycle from concept to production. We eliminate the I/O bottlenecks to achieve results faster across every workload. The team of Nvidia and Pavilion are shattering expectations. So what are some of Pavilion's unique advantages as it relates to feeding that beast of GPU-based systems, whether that's a DGX A100 or just servers with GPUs in them in general? Remember, one of Michael Kagan's quotes was, storage access is yet another bottleneck that needs to be resolved. Well, how does Pavilion address those issues as it relates to what Michael said? Storage access is yet another bottleneck that needs to be resolved. Well, not with the Pavilion solution. First of all, one unique advantage is our size. 4 rack units and up to 2 petabytes usable capacity. Next piece, our super high performance, but not just our high performance, but our ultra low latency. Our impressive read performance, but our equally impressive write performance. And as we walk through this presentation, all these performance numbers are validated by Nvidia. Our platform supports GPU Direct storage, not just for block, but also for file or any combination of that. Our platform in general gives flexibility to Nvidia customers to leverage block, file, or object in general on the same platform. Our platform is 100% based on open standards. We do Ethernet or InfiniBand. We have no host agents required, and we support all sorts of protocols from file, the NFS RDMA, to the block protocols of NVMe, TCP, Rocky, and RDMA, and even our S3 interface, all open standards. The second piece is a DGX typically comes with 6 internal drives. In our performance testing with some of our partners, we've seen that the storage performance in a DGX-A with its 6 internal drives If you took that same data and put that externally connected onto a Pavilion array, you'll have similar performance outside storage of a DGX versus the internal SSDs in the DGX. That gives you effectively unlimited capacity of storage outside of the DGX. So similar performance to internal SSDs. So flexibility in the Pavilion platform is driving some really unique capabilities and performance aspects for the DGX A100. As a summary, remember, think of our density, 4 rack units, up to 2.2 petabytes raw. And you can see those numbers as you look at each one of the numbers for a per rack unit. 20 million IOPS, 20 controllers, 40 100 gig Ethernet ports, supporting block, file, or object, and all these different protocols. Again, ultimate flexibility in deployment. But not just ultimate flexibility in deployment and best-in-class density, that's that performance density. Impressive numbers for block, file, and object. These are our numbers in a general performance leveraging FIO. If we look at that testing, we've seen from a general performance density perspective, we're one of the most flexible performance density product on the planet, but all at market competitive pricing. Let's relate that to the Nvidia performance testing we did, and remember that quote from Michael, high performance computing requires high performance IO. I'll show you these numbers in a little bit, but as we look at it using a tool called GDS-IO, is the ability to do GPU direct storage, which takes the data directly from a storage array and loads it through the NICs in the GPUs and directly to the GPUs. So this is a tool that is Nvidia, and we've delivered 182 gigabytes a second read and 149 gigabytes a second write to a single DGX-A in the block protocol. If we look at our file protocol, we're delivering over 191 gigabytes a second read at 1.75 millisecond latency. 118 gigabytes a second write at equally impressive latency. All of these numbers validated by Nvidia, leveraging their tool, GDS-IO, which is a tool, and these numbers are showing the GPU direct storage numbers. So impressive performance feeding that beast of the DGX. As Michael stated, storage can become a bottleneck in these big DGX solutions. Let's take a look at an example of one of the deployments we have with one of our customers, where they're deploying about 12 enterprise class servers, about $75,000 per server with GPUs in each one of those servers. And with that workload on those 12 servers, it can saturate one of our Pavilion boxes. Let's look at our testing as we did to the performance of that DGX A100, which is really turning this performance metrics upside down. A single DGX-A, it takes 2 Pavilion boxes to fully saturate a DGX A100. Now, that takes 8 rack units of storage for us, but 16 to 20 rack units of the competition. So Pavilion is really delivering in that price performance and that performance density and flexibility to feed the beast of the DGX A100. So let's look at these performance testing that we did to the DGX A100. In the Pavilion world, since we can support block, NVMe over Fabric RDMA or Rocky, or file, NFS RDMA, we've tested, per the request of Nvidia, using the tool GDS-IO to be able to test normal I/O from a Pavilion box through the CPUs and loading each one of the GPUs. That's using a tool, GDS-IO, and it's in the mode of X2. Then we're using GPU direct storage, which takes the storage directly off the Pavilion box through the NICs in the DGX and loads the GPUs directly. That's called GDS-IO XO. Both of those platforms and tools, GDS-IO X2 and XO, we've tested for block and for file. And in the coming slides, I'll reference the performance relative to each one of those platforms and testing. Before I show the performance number, let's do a bit of a legend and some nomenclature, kind of normalization. From the Pavilion world, when you see the charts, when you see GDS XO, that means GPU direct storage. If you see CPU X2, that means non-GPU direct storage. In other words, the traditional way you do it, data comes from the Pavilion box to the CPU, and the CPU loads the data into the GPUs. GDS XO, GPU direct storage, goes directly to the GPUs. So whether we tested in file or block, the logical testing configuration consisted of a single DGX A100 with 8 GPUs, and we leveraged the 8 cluster NICs. They're each are 200 gig NICs relating to each one of the GPUs. We leveraged those to connect to a Mellanox MSN 3700. We tested in Ethernet mode, so 8 200 gig ports and connections from the DGX. And then each one of the storage controllers, the 20 controllers in the hyperparallel flash array for Pavilion, had 100 gigabit Ethernet connections to that same switch. We tested with one box, and we leveraged, in air quotes, half a DGX, leveraging the NUMA zones and things to validate that we were leveraging only in half the platform, such that we could extrapolate those numbers times 2 to show that we can fully saturate a DGX A100, and that technique and style was validated by Nvidia, and the performance numbers that I'm going to show you are validated by Nvidia's GPU Direct team. So we tested with one box and extrapolated to 2 because of our linear performance and the way we configured the DGX A100 to ensure that we are only using half the memory and half the system and half the CPU, such that we could say times 2. So what are those performance numbers? I'm going to summarize in this one slide. The blue is block, the green is file. And if I look at the file side, in the charts themselves, the blue colors are the GPU Direct. The orange is the non-GPU Direct. In the Nvidia world, they like to talk about GIB per second, in other words, the base 10. So we delivered 178 GIB per second read for GPU Direct storage for file, and 70 for non-GPU Direct. As you look down on the left, and you can see the white letters, that file was delivered, we delivered that in 1.75 milliseconds. In the non-GPU Direct, it was 4.4 milliseconds. Now keep in mind, that latency is loading the data from the Pavilion box through the NICs or through the CPU and loading each one of the GPUs. The yellow numbers is what it takes of CPU utilization to deliver that work. One of the huge values of GPU Direct Storage is its throughput. As you can see, this almost twice, little over twice the throughput, but also uses significantly less CPU resources to deliver that same work. Keep in mind, in that DGX A100, there were 256 cores. So by almost reducing the CPU utilization in half, that saves a lot of cores on that CPU to do other things. So as we look at GPU Direct versus non-GPU Direct, which was the test that Nvidia wanted us to show, we've seen about 2.5 times greater bandwidth, 2.5 times better latency, and almost 1.8, almost 2 times better CPU utilization from the file perspective. You can see those same numbers on the block over to the right, 170 gigabytes a second read, 69 gigabytes a second for the non-GPU Direct. In each one of those, file or block, look at the right performance. As you look at the competitions who have published numbers as well that you can go and look online to get, you'll see those numbers from a write perspective are materially better in the Pavilion world. Our milliseconds of latency is materially better, and the amount of rack units of hardware it took to deliver that was materially better than the competition. So the key value for us is our dense form factor, 8 rack units, 2 4RU chassis, our ultra low latency. In other words, our latency was incredibly impressive. Our impressive write performance as well, and we required no host agents. This slide and the next slide are just supporting slides that give the details from the slide I just presented. Shows whether it's block or file, really looking at it in the context of bandwidth, latency, and CPU utilization, GPU direct versus non-GPU direct, right? Same thing, comparison, block versus file, just a little different look depending on how you want to analyze the data. Both this slide and the previous slide are best viewed in just looking at the presentation in general from a data point perspective. So let's compare those numbers a little bit to the competition as it relates to GPU direct storage. You can see the various categories from read bandwidth to read latency to write latency to rack units. Thing to take away from this slide is put a check by Pavilion in every one of those categories. There's no competitor out there that beats us in any single category, let alone all these categories. As you look at these numbers, I'm comparing two competitors. The first number is one competitor, the second number is a second competitor in the file space. Read bandwidth, we do 110 to 117%. In that same test, the latency is 9%, the latency of the competitor to 73% the other competitor. From a write bandwidth, we're 366%. The first competitor, almost 170, the second competitor. At a latency of less than half of the competitor, and the second one does not publish. From a physical size perspective, we're 40% the size of the first competitor and 73% the second, and neither one of those guys support block. So again, anywhere that you look at it, our performance relative to our file and our block is unsurpassed in any one of the categories. Compared to the competition, put a check mark by Pavilion. But as we said, we're delivering incredibly impressive performance, almost 191 or 170 GIB per second, basically saturating a DGX almost at line speed, which was one of the quotes that Michael Kagan spoke of at the SC 2020 summit. But not everybody needs all that performance to a single DGX, to a single server. That's the value of Pavilion. You may have an environment where you have multiple HP or Dell or IBM or Lenovo servers that have GPUs in them. And you don't need any one server that much throughput, but you have several servers that can be serviced by a Pavilion box. You may also have your environment, one single DGX that needs that incredible performance. But that might be unlikely, and you may have multiple DGXs that you need very, very good performance that you can share that same storage on a Pavilion box. So in other words, multiplex multiple DGXs to a single or multiple Pavilion boxes. So whether you're using GPUs inside another vendor servers or you're using a DGX, whether that's a single box that needs incredible performance or multiple boxes that needs really good performance, Pavilion can deliver, whether that's scale out or scale up. So now let's just imagine a world that's pretty hypothetical, but imagine if you could fill a rack of DGX A100s. That would fit 7 physically in them. And you can fill a rack of Pavilion boxes, and we'll call that 10 of those boxes in there. In those 2 physical racks, your compute ecosystem would be 35 petaflops of AI per rack, 70 petaops, with 7 DGX A100s, over 14 terabytes of RAM, 4.48 terabytes of memory, and 890 gigabytes a second read, 550 gigabytes a second write, and 20 petabytes of usable storage. When you look at this slide, it's just a concept, whether you're going to be using Pavilion for block storage, whether you're going to use Pavilion for file storage, or you're going to be leveraging some sort of external file system like BGFS, Lustre, or Spectrum scales. The Pavilion solution gives you ultimate flexibility with incredible read and incredible write performance, enabling the DGX A100 To learn more about us, check out our website at pavilion.io, or of course, call or email us. Thank you.